Hello and welcome to another walkthrough. Now this time it will be the 2023 Senior Math Challenge paper, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Okay, here's the paper and I'm going to start the timer now. Okay, let's go. We have an hour and 30 minutes. And then I'm going to write the paper around here for this one maybe. Okay. Alright, so number one. What is the value of that? Well, okay, the way I would go with this is to just, do the math. So number one is just square root 2023 divided by, 4, and then that's 7. Well, you got to divide the thing, right? So let's do mental division here. 7 divide 20, we get 2. So it's 14, right? And then we have 62. So 7 times 8 is 56. So that would subtract to get 6. And then you carry that to 63. So 7, 9 is 63. And then because I happen to know that square root, 17 squared is 289, so that's going to be 17. So my answer would be choice C here, yeah? That's it, number 2. Okay, so I'm just going to move this down. Okay, number 2. You can see the question, right? Yeah, okay. What is the difference between 1/3 and that? Okay, so the difference between 1/3, which is 1/3, and that, you need to know that that is going to convert to 333 divided by 1,000, right? So I would just do the fraction here. So I cross multiply and just find the difference. So that would be 1,000 minus 999 over 3,000. So you'd have to multiply the denominator as well. And then you would get what? That would be 1,000 minus 999, which is 1. So 1 over 3,000. And that would be choice C there, option C. Okay, the next one. Next one, yeah, the first few questions are quite easy, right? Okay, so number 3, the base of a triangle is increased by 20% and its height is decreased by 15%. What happens to the area? Well, because we know that the area of a triangle is half base height, right? I mean, the new area, which is also half base height, but the base is, shorter. The base is longer by 20%, so that's 1.2b, right? You need to know that. In an increase of 20% is basically 1.2 times the previous one. And the height is decreased by 15%, so that's 0.85, the height, right? So you see, if we multiply the 1.2 and the 0.85, we're going to get a new factor to multiply the 1/2 BH, yeah? So let's see what we got here. So if I multiply 1.2 and 0.85, so I'm going to do 12 over 10, that's 1.2, times just 85 over 100. And then I'm going to try simplify these fractions using just cancellation. So if I do 5, cancel that, I get 20 here, and that's 17, yeah? And then I can do 2 here, so 2 cancel that, I get 6, 2 cancel that, I get 10. Well, that's basically just 6 times 17, which is, this is 42, and then 102. Yeah, 102 divided by 100. So the factor is 1.02. So that's like an increase of 2%. Yeah? So that's going to be choice D here. Okay? Yeah, that's the way to go, because you need to know that when you multiply the factor out, I didn't multiply the half because we already got 1/2 BH here. So, I mean, if we write this down again, it would be 1.02 times 1/2 BH, which is the same as before. So this is basically 1.02 times the previous one, which is 2% increase. Yeah, I hope that's fine. Number 4, I'm going to do it here maybe. Number 4, in 2016, the world record for completing a 5,000 meter three-legged race was 19 minutes and 6 seconds. Hang on, let me zoom out a bit. It was set by Damien Thacker and Luke Simmons in Sheffield. What was their approximate average speed? Okay, so the average speed, VAVG, is just the total distance divided by total time. Yeah, we then need to find the total distance from these two competitors, which will be 5,000 plus 5,000, right? That's the total distance. And then the total time, well, note that we want kilometers. Yeah, we want kilometers per hour there, right? So that would be 1 kilometer. Yeah, 5,000. Sorry, no, 10 kilometers. Yeah, because 5,000 is 5 kilometers. And then the time in hours, well, you have to do 19 minutes plus 6 seconds. I'm going to leave it there first. And then 19 minutes plus, hang on. What was the approximate average speed? Wait, what? The world record for this was 19 minutes and 6 seconds. It was set by Damien Thacker and Luke Simmons. Oh, sorry. This is just, yeah, okay, no, it's not that. It's just, so this is already kind of like the average 5,000 meters, and they got from the average time there. So, okay. Average speed. So yeah, I'm gonna go with just 5 kilometers divided by 19 minutes and 6 seconds, converting to hours. Well, we're not gonna do all the seconds, because if you do in seconds, that would be, if you convert 19 minutes to seconds, you would have to divide by 3600. That's going to be complicated. So I'm going to round this to 20 over 60, and that's going to be in hours, so it's 1/3 hours. Yeah, because I look at the choices and they are kind of like different. They're quite different, so I could round it like this. And then you see I got 15 kilometers per hour. That should be close enough. I mean, not exactly right, but it should be it should be close to that, right? So we're going to go for option C. All right. Okay, this one I might need to do it in the paper here. So question 5, 3 circles with radii 2, 3, 3 touch each other as shown in the diagram on the right here. What is the area of the triangle formed by joining the centers of the circles? The area. Okay, so radii 2, 3, 3. All right, so I'm just going to fill those in. 2. Hang on. So 2 here, 2 here, 3 here, 3 here, and 3, 3. All right. Well, we need to find the area of this triangle, right? Let me think about that. Okay. So basically that's 5, 5. So this one, 5, and this one is also 5. We know that that's going to make it an isosceles triangle. Okay, interesting. How are we going to find that area? Well, we could use sine and cosine rule and just use the 1/2 AB sine theta, but I'm just thinking, is there a better way there? There should be. Yeah, I'm thinking there should be. I mean, look, it feels like I can draw this line and it's going to be tangent to that, which will make this a perpendicular. So that's like the height there. So basically this is just 3 and 5, so that's going to make the height 4. Let's try that, right? So the area would be 1/2 times the base, which is 6, times the height, which is 4, so that makes it 12, which there is an answer for. But I mean, if I have time later, I'm going to come back to verify this using sine and cosine rule, because like it's a bit risky to assume that that's going to make a right angle triangle, but it feels like it should be. Yeah. this should be a tangent because this is equal length, right? 3 and 3. So, and this is isosceles. So yeah, this should split in half. Yeah, definitely. Okay, it works because this is equal. So that means when you draw this down to this, it's gonna be a bisector of this line, and that's the property when you draw a height from an isosceles. When you draw it like this, it's gonna be perpendicular while splitting the line into two halves. So that should be perpendicular. Yeah, okay, definitely. No need to come back now. Number 6, how many lines of 3 adjacent cells can be chosen from this grid, horizontally, vertically, diagonally, such that the sum of the numbers in the 3 cells is a multiple of 3. 3 is adjacent cells in all the different ways, horizontal, vertical, and diagonal, such that the sum of the numbers in the 3 cells is a multiple of 3. How many ways, basically? So, okay, to get a multiple of 3, right, we need to think a big picture first. To get a multiple of 3, you can have all of them being multiple of 3, or none of them are multiple of 3, but when they add up, you should get a multiple of 3. So that's going to be done by, well, okay. So we have a multiple of 3, a multiple of 3 plus 1, and a multiple of 3 plus 2. Those are just the 3 types we see here. Now, if we add these up, right? So these are all adjacent. So it's like 1, 2, 3. If we find any 3 adjacent numbers, you're gonna have them added up and become a multiple of 3, like 1, 2, 3. That's 6, so divide by 3. 2, 3, 4, that's 9, divisible by 3. So it's just 1, 2, 3, 2, 3, 4. I'm just going to use lines like that, yeah? Yeah. And so on each row, we have 2. Can you see that? On each row, we have 2. Okay, now we have 8. And then, what about the vertical here? 1, 5, 9. Is that going to work? Yeah. This is going to work. So 1, 5, 9. And what about 5, 9, 13? 5, 9, 13 also works. Yeah, multiple of 3. Yep. So we get 2 each as well. So that makes it 16 now in total, right? 16 now in total. What about diagonal? Diagonal, like 2, 6, 11. Well, 2, 6, 11 is 18. So that's also a multiple of 3. And what about 2, 7, 12? 2, 7, 12. Yeah, it's also a multiple of 3. So I have what? 1, 2, 3, 4. That's it. 4 more. So 16 plus 4. Hang on. Okay, I'm missing something. So I get 8 from the vertical and 8 from the horizontal. And 4 from the diagonal. Okay, so 1, 2, 3, 4. Oh, it's the other way. There's another way, right? There's this way. I forgot this one. So another 4 there. So that should be 24, I think. So I'm gonna go with 24 there. Yeah. Okay. Right. Number 7. Just gonna use that 2 again to write here maybe so that you can see bigger. Number 7. It's too big. A sequence begins 2023, 2022, 1, ... After the first 2 terms, each term is positive. Each term is the positive difference between the previous 2 terms. What is the value of the 25th term? Okay, so interesting, right? Okay. It feels like, okay, to go from, all right, so I'm not sure about going from 2023 to 2022, but the 2022 to 1 is basically just to subtract this from this. So if you subtract this from this, yeah, you get 1, right? So if I keep going with that, subtract this from this, I get 2021, yeah? Probably not going to work. Each term is positive difference between the previous 2 terms. Positive difference. That means it's going to increase. positive difference between the previous two terms. So it's going to keep increasing. Yeah, it's going to keep increasing. Okay, I don't see how here. Okay. Well, how about 20. Oh, hang on. To go to this, we subtract, right? By 1. Okay, let's just find the common, like the differences first. So we subtract that by 1, and from this to this, we subtract by 2021. Yeah. Is it going to be plus 1? Or maybe plus 2021 to get 2023, and then I'm going to do plus 1 here, 2024. And I mean, if I'm going to take my chances here, how about I'm going to do the same thing? So that's going to be minus 1, so 2023, and then minus 2021, so we get 2 here. How about that? Yeah, does that work? Like, okay, do we have positive difference from, after the first two terms? Like we have, yeah, this is, hang on, after the previous two, why is it, yeah, the previous two positive difference, no, that's not working. Okay, I have no idea about this. I'm gonna skip this one, all right, honestly. Okay, number 8. What is the value of that? All right, so I think the way to go with this is to convert the recurring fractions, the recurring decimals, to fractions. So it's actually 99 times. Well, you should know that when you have 0.49 and 49 recurring, it's just 49 divided by 99. So the number of 9s in the denominator will be the same as the number of recurring digits there. So there are 2 recurring digits, 4 and 9. So you just do 99. Okay, just like that. Yeah, and this is 2-digit decimal, so you have 9 and 9, so 2 9s there. And for this one, it's just 4 over 9, right? You should know that. Okay, so that means if we do multiply 11 here, I'm going to get 44 over 99, just multiply by 11 over 11. So that's going to make the brackets become 5 over 99, and that's going to be 5 if you cancel them. So the answer is just A here, number 5. Okay. Number 9, when completed correctly, the cross number is filled with 4 3-digit numbers. What is the asterisk? Okay. The cross number is filled with 4 3-digit numbers. So across, down. I think across is going to be from left to right. So with the 4 3-digit number, when completed correctly, the cross number is filled with 4 3-digit numbers. Yeah, the cross number is the whole thing, right? Okay, so we're gonna fill with 4 3-digit numbers. What digit is asterisk? Oh, okay, 4 3-digit numbers. So 1, 2, 3, 4. I see. Okay. Right. So across number 1 and cross number 3 This is down number 1 and down number 2. All right, so I'm just interpreting the question. This is the first time I say this. Okay, so a square number, yeah, with a cross here. So 1 something 2. Well, we have 1. Okay, so it should be more than 10. 11, nope. 13, 12, nope. 15, 14, nope. 17, 18. No, that should be less than 13. Wait, what? 11 is 121. 13 is 169. 14 is 196. 15 is 225. What? So maybe I'm interpreting the question wrong here. A square. Across number 1 is a square. A square? Square of what? Okay, let's look at the other ones first. Like down twice of 5th power. Okay, twice of 5th power. 5th power is something to the power of 5. So 1 to the power of 5 is 1. 2 to the power of 5 is 32. Well, twice times 2 times 32 is 64. So let's do 3 to the power of 5. 3 to the power of 5 is 981 times 3. So that's 245, right? And we have to do twice. So that's probably not. Wait, hang on. Twice of 5th power. Oh, wait. Oh, no, that's 122, 142, 112, 122, 102. A 4th power. A square. A cube. Look, if I just sub this in, each one of them, nothing gives me a square number. So probably something, I'm missing something here. So 142, 162, 122, 112, 102. Nothing is a square number. So I'm gonna go with 6, yeah, because at least 16 is a square number by its own. So let's try. Okay, I'm just guessing that it's just these 2 cells and not all of them when it says across. Yeah, let's go with that logic. I'm not sure here, but across 3 here, so it's 3 something. Get a 4th power. 4th power. So 2 to the 4 is 16. 3 to the 4 is 81. Okay, that's wrong now. A 4th power. 2 to the, yeah. Okay, interesting. Wait, hang on. These are not field numbers. They are just, okay. They're just a number, like the item numbers. Okay. Nothing is filled here. All right. Okay. Let's do it again. Square number. Okay. Yeah. All right. I understand it now. Okay. So a square number. We have what? 3-digit square number. We have 144, 121, 100. But you can't use 100, can you? Well, maybe we can. And then we have what? 1, 69 and 196. That's it, isn't it? No, that's more. Okay. And then across number 3, a fourth power. Okay, fourth power may be easier because we don't have a lot of options. So for the fourth power to be 3-digit, we have 3 to the power of 4, that's 81. 4 to the power of 4, that is 256, yeah. And 5 to the power of 4, that is 625. 6 to the power of 4, I believe, is 36 times 36. Isn't that over? Yeah, that's probably over 1,000 already. So we only have 256 or 625. Interesting. Okay. And then a cube for number 2 here. Well, a cube to be 3 digits. We have 5 to the 3. 4 to the 3 is not. So 5 to the 3 is 125. And 6 to the 3 is 216, right? Yeah. And 7 to the 3 is 289. Hang on. Let me just do the math there. Yeah, 243, sorry. And what do we have? 8 to the 3 is 512, I think. 9 to the 3 is 729. Okay, there's a lot of choices here. And then, yeah, 10 to the 3 is no longer applicable now. Okay, so if I only use this and this, right, which is these sets of options, if I fill 256, let's go with 256 here. This is going to be 216, right? Yeah. So I go with that and that. I can use repeated digits, right? Let's assume that. And then what would be the square ending with 2? Okay, do we have that? Square ending with 2. 25 times 25 is 625. 20, but within 100. No, it's not within 100. Yeah, almost fooled myself again there. Can be any number with 3 digits. Okay, let's do this one first. A down one here. A down one. Twice a fifth power. Twice a fifth power to get 3 digits. So a fifth power, like 2 to the 5 is 32. That's going to be not going to be 3 digits. 4 to the 5, no, 3 to the 5 first. 3 to the 5 is 81 times 3. So that's 243. So 243 multiply here. That would be, no, that's not going to work. It's so let's list the choice here. So it's 486. Twice 4 to the 5. Yeah, let's do 4 to the 5. So that's 4 times 4 is 16. 16 times 16 is 256. 256 times 4 is, yeah, I'm going to do the math there. 1,024. And then that's already over 3 digits. So you only have one option here. I didn't see that. Okay, so you only have one option for the down one here, which is 486. So we got to put that first, 486, and it's fixed here. And this will make this 625. I ticked the wrong one there at first. This should be 625 now. And then 625 ending with 5, so I get 125 here, and that's why they put this at last. 441, I believe this is 4 and 1, so I believe it's 21 times 21. You can try that. You should get 441. Yeah, so it's number 4 here, choice D. Ooh, that took a while. Number 10. Okay, we add 28. How many of the numbers blah 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 are factors of the sum? Okay, factors of the sum 22 to the power of 2024. Okay. So the way to go with this, I would say, is to get the pattern of the powers of 2. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and then 16. And you will see that the ending digits will keep appearing as a pattern. So the next one will be 32. Ending with 2, see? And then 64, ending with 4, see? And then the ending digit will keep going in a loop like this, 2486, 2486, right? So we know that 2 to the power of that, well, that's a multiple of 4. So when you divide that by 4, it can divide by 4. So that means the ending digit will be 6. Yeah. So this is 6 something something 6, maybe a lot more. And what about that? Well, 1 less than the 6 here, so that's going to end with 8, right? And that's going to end with the previous one, 4. Okay, now imagine you have big numbers, blah blah blah, and then all of them, well, each of them will end with 6 and 8 and 4, and then you add them up. So you're going to be doing a lot of numbers here and an 8 here and a lot of number and 4. So when you add them up, 6, 8 and 4, right, in the last digit here, focus on this one, you're going to get what? Some big numbers, right? Some big numbers, some big number, and then it ends with what is this? 18. So you're going to end with 8. And then something to keep over to the other digit is 1, right? So okay, now we're going to consider, like, what can we divide this? All right, okay, that's one way to go, but probably not helping here because the factors, yeah, they are quite big numbers. It's not like 2 or 3. So if it was 2, if there was 2, then we can already say that 2 will be one of them. But okay, the other way that I see how to do this is to think about, well, let's factorize them, yeah. So all of them have a factor of 2022. If you pull 2 to the power of 2022 out, the first one will be left with 2 to the power of 2. Second one 2 to the power of 1, and the third one is 2 to the power of 0 or just 1. Yeah. So what are we getting here? It's 2 to the 2022 times, this is just 4 plus 2 plus 1, that's 7, right? Okay, so if we have a 7, that's definitely one of them, yeah, because we are finding which of these are factors of this number here. So I'm just gonna rub out this thing. Probably not that useful anymore. Well, 2 to the power of 2022, definitely there is an 8 in there. So if I can split this, I can have 2 to the power of 3 times 2 to the power of 2019, right? So 8 is also a factor. Okay? Now imagine you have a lot of 2's there. There's no way you can get 9 to be a factor, because to make 9 a factor of this thing, you need 2 3's. So there need to be 2 number 3's. But there ain't. So 9 is not. 6 is similar. You need 1 2 1 3. But you don't have any 3 there. So 6 is not. Number 10, you need 1 2 1 5. You have one number 2, but you don't have any number 5. So 10 is not going to be a factor. And that is it. So the answer is just 2 of them, which will be the factor, yeah? Okay. The next one is probably quite fun. It's logic, yeah? I'm going to keep the working here. Okay, when Lou, Xander, Yasser, and Zoe make the following statements, okay, the way to go with this, right? Also, okay, we are finding the possible number of people telling the truth. The easiest way to go is just to go with the flow. I mean, do you feel like making this person telling the truth first? I feel like that, so just go with it. So we're going to assume that when Lou is telling the truth, if he tells the truth, that means Xander is lying, because that's the truth, that Xander is lying. So Xander is lying. Let's put an F here because he's lying. Okay, what is he lying about? He is lying that Yasser is lying. So that means Yasser needs to tell the truth, because the opposite to Yasser is lying is Yasser is not lying, which is telling the truth. So we put a T on Yasser there. And then Yasser says Zoe is telling the truth. Then we're going to put a T in Zoe here. Now if Zoe is telling the truth, because we carried that on from the assumption that Wenlu tells the truth, Wenlu is telling the truth. Well, that doesn't contradict anything. because Zoe is telling the truth, which also supports that Wenlu is telling the truth, which was the case because we assumed that Wenlu is telling the truth first. So everything works well here. That means we get 3 of them telling the truth. I mean, you might go and answer E, but we never know. Because look at the options. There are 2 options that says 1 or 3 and 2 or 3. Would you be so certain to go with E? I wouldn't. So what I would do is do the opposite. So now let's do in red color. I'm going to put Wenlu telling a lie, right? So if Wenlu is telling a lie, then that means Xander is telling the truth. Just the opposite. So this would be T. I think everything is just opposite here, right? So you can try that. So Xander is telling the truth. That means Yasser is lying. So Yasser is lying. This is F. Yasser is lying. So Zoe is telling a lie, right? So F also this. Zoe is also telling a lie. And you have 1. 1 of the people telling the truth. So the answer is either 3 from the blue case and 1 from the red case. So the answer should be option B, 1 or 3. That's the way to go, all right? Number 12, the greatest power of 7, which is a factor of 50 factorial, is 7 to the power of k. Well, okay. The greatest power of 7, which is a factor of 50 factorial. Okay. So this is just the definition of factorial. You should all know that. Okay, a factor of 50 factorial. So 50 factorial is basically 1 times 2 times 3 times blah, blah, blah. And then the last one is 50. Well, let me just do also 59 and 50 because I happen to recall that 49 is 7 squared, right? So we have a factor of 7 there, or multiple of 7. Now, so 7 to the power of something can divide into this. Okay, so if we say, okay, let's assume first that k is 1. So that's going to be 7 to the power of 1. So we keep increasing the power. Of course, the options don't have 1. The minimum is 4, but let's make it simple first. So if I put 1 in there, that means this must divide this. Or does this have a factor of 7 in it? It does, because we have 49 here. And if I put 7 to the 2 here, it can also divide 49. So 1 and 2, of course. Now let's start with the smallest one, because the options have 4. So we should take 4. 2 of them can already, you need to know that, well, 7 to the 4 is 7 to the 2 times 7 to the 2, right? So one of them can already divide 49. Yeah? What about this one? Well, imagine 1 to 50. Along the way, you have 7 around here and 14 somewhere. That's already how many more 7s here? You have 1 7 here, another 7 here. So this can already divide. Now, if we see the behavior here, we can get smarter because you can just keep going with the 7 here. So whatever numbers have a factor of 7, like 28, 35, and then the last one, 49, of course. Then you can count how many 7s can there be. 1, 2, 3, 4. Because this is 7 times 1, this is 7 times 2, 7 times 4. Oh, I forgot the 21. Okay. Self-correction here, yeah? So this is 7 times 1, 7 times 2. So there are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yeah, but then there are 2 7s here. So 7 7s. So the maximum is 7. That's it. All right. Okay. So the answer is D there for me. Next, question 13. PQRST is a regular pentagon. Point U lies on ST such that the angle QPU is a right angle. What is the ratio of the interior angles in the triangle? All right. So we should draw this roughly first. Probably I'm going to use this tool again. I'm going to put it here maybe. Okay. So let's draw that out, right? A regular pentagon looks like maybe like that. And we know that each of the interior angles would be 108 because the sum of the interior angle is 540. It's just 180 more than a quadrilateral. Yeah, if you divide that by 5, you get 108. So if this is a regular pentagon, of course it is, then each of the interiors is 108. Now point, so let's make it P, Q, R, S, T. And then we have point U. Point U lies on ST. Yeah, point U here, such that QUP is that? Is a right angle. So that should be a right angle, right? What is the ratio of the interior angles in the triangle PUT? So PUT, this is U, PUT. So this triangle here that we need to figure out. So the triangle PUT, right? Let me draw here. Okay. We definitely know that this is 108, right? Okay. And, well, 108 seems to be probably the largest angle. Yeah? It should be the largest angle. Do you feel like that? Because it's an obtuse, right? So the way I would go with this is to check the choices because it's the largest one in the triangle. So if you take choice A, option A, 6 is the largest portion there, right? It's the largest portion. So you got to check here, if it's 6 there, then 6 must be a factor of 108. Is it? It is, right? 6 is a factor of 108 because 180 divided by 6, you get 18. And you can use the choice here as your leverage, because if you know that this is multiplying by 18 to get 108, this should also be multiplying by 18. I mean, let me write here. So if this multiply 18 to get 108, this should multiply 18 and this should multiply 18. Or you can sum them up, you get 10, and then you multiply 18, you get 180. So this is a valid choice. Let's check others. This one is probably not, because 108 is not divisible by 5. Is 108 divisible by 8? Nope. 108 cannot be divided by 8, can it? This is not a valid choice. What about 4? 108 divided by 4, yeah. You get what? You need to divide 4 by 28, right? Is that? No, 27. Yeah. Now, again, you got to multiply everything by 27, and you need to check if they all add up to 180. So 2 plus 3 plus 4, you get 9. 27 times 9 doesn't seem like it's going to give you 180, so not a valid choice. What about this? Well, this is 4 again, so you need to multiply 27. So that's going to be all 7 times 27. That's not going to give you 180. So the answer is already choice A, because you just check the choice, which one works to be a triangle. Because we know definitely that one of them is 108, right? I didn't do any hard stuff here, just using the choices as leverage. I mean, of course, if you don't have the options, there should be some proper way using the definition of a pentagon and work out the geometry in there. But come on, there are options here, and this is a speed test, right? Number 14, the points P, Q, both lie on the circumference of the same circle whose center is the origin. What is the sum of two possible values of D? All right. So you should all know, you're doing A-level now, or something equivalent, that the equation of circles is that equals r squared, right? So if we plug this into the equation, they should give you the same radius, basically. So basically, if I put D in, so D minus H, wait, hang on, lies on the circumference of the same circle whose center is the origin. Oh, is the origin, so it's much simpler than that. It's just x squared plus y squared equals r squared. Okay. And then, well, because, yeah, we need 2 points there. We have 2 points on the circle, so we can plug D squared plus y minus D is also D squared here, equals r squared, and then equals the other one is 12 minus D squared plus 2D minus 6 squared, yeah? So that's just using the circle equation, basically. That's just it. Now I'm gonna just do that. Okay. So what do we do next? Well, we can continue with that because you can simplify this, right? So this is 2d squared equals, well, the right hand side there, you just expand using complete square formula. I mean, you should remember this is 144 minus 24d. I mean, I know how to expand the square quickly there. You should also know that. This is 4d squared. 2 times 2 times 6 is minus 24d plus 36. Yeah, just expand them all out. And then I get some cancellation here, and we need the sum of possible values of d. Well, we're just going to make this quadratic first. So on the right side, I have 5d squared minus 2, I get 3d squared. And on the right side also, I have minus 48d. And on the right side also, I have plus 180 equals 0 here. Well, of course, you can simplify that by 3. You're going to get d squared minus 16d and plus 180 over 3, which is 60, of course. I forgot. Okay. Yeah. Now, you need to know that when you have a quadratics, the sum of the roots will be the second term divided by the first term. As in, when you have ax squared plus bx plus c equals 0, this is a bit more than pure math, like it's probably in further math, but you should know it. The sum of the roots of x is going to be equal to minus b over a. And the product, which is the roots multiplied, you get c over a. So in this case, we want the sum, right? The sum of the possible values of d. So it was then minus 16, which is 16 over 1. So that should be 16 then. Choice E. Yeah? So that would be the answer there. Okay, hurry up. 15. In Bethany's class of 30 students, twice as many people played basketball as played football. So basketball, I think B, football F maybe. So twice as many people. So B equals 2F there, I'm going to write. Twice as many played football as played neither. Okay, neither maybe N. Which of the following options could have been the number of people who played both? Alright, so let's do a Venn diagram, right? Okay, so let's do a Venn diagram, maybe. So let's do it here. Okay, so we have a Venn diagram looking like this. Okay, and then like that. Twice as many people played football as neither. So let's say neither is N. Yeah, let's put neither as N because it's outside the two circles there. But then we have N to be F over 2, right? Yeah. Oh no, F is 2N, sorry. So F is 2N. So if I put this as X, which is what we want, the number who played both, right? X here. That would be F minus X. But we know that F, which is football, I forgot to say football there, and this is basketball. F minus X is basically 2N minus X, right? I'm just trying to make everything in terms of the same variable, which is 2N minus X here, because we know that F equals 2N on the top right there. And because, well, we know that B is 2F, but F is 2N, so B is 4N. So that would be 4N minus X, right? Okay? So what's the point here? Well, at least we could say that if we add all of them up, we get 30. Yeah? So if we add all of them up, we get 4N minus X plus X, so they cancel, and then plus 2N minus X plus N equals 30. So here is 7N minus X equals 30, and X is 7N minus 30. All right, let's consider that, yeah? Let's consider what's possible here. Well, if you get 19, N must be an integer. N, some number here, must be an integer. And N must be such that 7N minus 30 should be at least greater than or equal 0, right? Because X is the, the number of people. Okay, look, we can check choice here. if x is 0, like the minimum number, it probably can be. If x is 0, n would be, you just solve this equation, right? Okay, we're just going to do this. I'm going to make n the subject now, because we're going to inspect the choice here, working backwards. So x is 7n minus 30, right? Wait, hang on. I should make n the subject. N equals x plus 30 divided by 7. So if you plug the choice, the option E, that's because that's the value of x, right? If you plug option E in, you get a non-integer number, which is not right. If you plug 5 in, 5 is possible. So I'm going to write down here, 5 is possible because you get 35 divided by 7. That makes sense. If you plug 9 in, not possible. 39 is not divisible by 7. If you plug 14 in, 44 is not divisible by 7. If you plug 19 in, 49 is divisible by 7. So, 5 and 19 now. Now let's see further, 5 or 19. This is the value of x, right? Well, if you have 19, let's do 19. 19 as x. Well, that's going to be what? So what was n again? N would be, if x was 19, then n would be, so n is 49 divided by 7, so n would be 7. So that would be 28 minus 19. That makes sense. And that would be 14 minus 19. That doesn't make sense. You just find the value of n and then plug it back to your Venn diagram. If something doesn't make sense, maybe this choice doesn't make sense. So we shouldn't go for this one. We should go for the 5. So I'm just going to go with 5 already, yeah? Because the other one doesn't make sense, and there are only 2. So use some logic there. Okay, maybe it's going to be faster. 16, G and H are midpoints of the 2 adjacent edges of the cube, like that. A trapezium-shaped cross-section is formed cutting through G, H, and 2 further vertices. As shown, the edge length of the cube is 2 root 2. Okay, what is the area of the trapezium? Okay, so again, you want to calculate the area of this kind of trapezium, you need to know the height and the 2 parallel sides, right? And then you're home free because it's just half times height times a plus b if you forget. So we need to find this top side and this bottom side and the height. Well, the height I think we already know because the edge length of the cube, which is this guy and all other guys, is 2 root 2. So the height I think is already 2 root 2 in it. Hang on, or is it not? Oh, hang on. That's a bit slant. That's not straight up, right? That is not straight up. It's like leaned over to one side. That's tricky. Okay, yeah, all right. We got to be careful here. Okay, at least we can find the b. That's the diagonal of 2 root 2 and 2 root 2. So it's the hypotenuse of that. Well, the quick way is to do, when you have an isosceles right angle triangle like this, is just the side length, the 2 legs there, which are equal as an isosceles, just multiply that by root 2. Trust me, it's going to work. You can just do a Pythagoras. It's just one of them multiplied by root 2, so you're going to get 4 here. So this is 4. Okay? And then we already know that that is 4. Well, this seems G and H are midpoints, so that means, if I can zoom in here, this is, because the whole thing here is 2 root 2, so that's just root 2. This is also root 2. Again, this is 2 root 2. Wait, no. Root 2 times root 2, using the same trick, so I get 2 here. So the top is 2, the bottom is 4. We are good now, almost good. Now we need to find the height between that point and that. How are we going to do that? Okay, let's see. Aha! Okay. So this is a right angle triangle, right? Yeah? Okay, so we need to find this red height, but let's draw the full right angle triangle here. I mean, we can find this side because this is on the face, on this face, right? So this side is from a right angle triangle, don't you see? Yeah, so this is again root 2. This whole edge is 2 root 2. You can find the hypotenuse of this triangle on the left edge, on the left face. So what is that? 2 root 2 to the power of 2 is 2, 2 root 2 to the power of 2 is 8, and square root that is root 10. So this is root 10, and okay, what is this? Isn't this going to be because this is a diagonal of a square and this is a midpoint, I think this is going to be the midpoint of the mid length here, right? And because this is 4, so this will be 2. So that means this should be 1. Okay? It's just a quarter of that diagonal. That means the height here would be square root of 10 squared, which is root 10 squared, which is 10, minus 1 squared, which is 1. So that is 3. So the height is 3, so that means it's going to be 1/2 times 3 times 4 plus 2 right here is 6. So that's going to be 6. There's no answer. Okay. Right. Okay. So something didn't make sense then. Let me check my math there. Probably the height here is wrong, I think. Probably not that simple. That's definitely root 10, right? Because this is 8 times, yeah, plus 2 is 10. This is right. This is probably not 1 then. Okay, the logic was failing there. Okay. So the height. How do we find the height here? Yeah, again, I don't think it's just, I don't think it's just 2 root 2. Or is it? No, it's not. It's not, no. If it's 2 root 2, then the trapezium would actually look like this. It's more like a plane, a cross plane like this. But it's leaned over a little bit. How do we find that length? Okay, imagination is more important here. Okay, this is tricky. Not sure about this, but it's just the height, right, that we don't know. So let's make that h, and then it's 2h. So 2 times something. I'll probably go with 4 root 5. Okay, so I got, I mean, okay, more or less this should be close to 1. Let's go with that. But it's not, right? It's just my sense telling me it should be close to 1 because we use that logic there, but it's wrong. But I mean, if I would do this, I would go with this. The way I would go with this is assume that h was 1. So you would get, not, this length was 1, so that h was 3, right? And then you would get 3. I'm just going to find the answer that is closest to 3. And nothing is closest to 3, basically. Oh, wait, what? This is 1/2. What did I do? Okay. Wait. Oh, no. I was right. That was stupid. I was right. It's just I put 1/3 rather than 1/2. Okay. That was 9. Sorry. Okay. Number 17, the number m equals that is smallest number which uses all the non-zero digits once, which has property that none of the parts of its consecutive digits makes a prime number. For example, 5, 6 digits, the 5th and the 6th digits of m makes 63, which is not prime, and is the largest number. Okay, so basically we're going to find a 9-digit number where none of any 2 adjacent numbers make a prime number. Okay, now the largest way to make it is to start from number 9, right? Okay, so yeah, you start from number 9. Let's just put 9 seeds here, like that. 4, 5, 6, 7, 8, 9, yeah, and we're going to put number 9 first here. we're just going to go with 5, 8, 7, 6, 5, 4, 3, 2, 1 and see if there's anything wrong with this, right? And the two digits we want is the 5th, which is this guy, and the 6th, which is this guy. Yeah. Okay. So is there anything wrong with this? 98 is not a prime. That's a tick. 87. Is it not a prime? Well, if you add up the digits 8 and 7, 3 is divisible. Like 3 can divide 87. Because when you add up, you get 15. 15 is divisible by 3, so it means 3 can divide 87. That's just a trick to check. Divisibility test, yeah. 76, yeah, is an even, so it's not a prime. 65, not a prime. 54, not a prime. 43, however, is a prime. So this does not work now. Okay, now should we just, because these work, but the remaining here don't, so how about we just swap around 3, 2, and 1 to see. Because one of the choices already says 5 and 4, so we might be lucky. But let's swap around. So we have other cases to be 2, 3, 1, 43 is not already right, so it has to be some other number, or 2, 1, 3, or 2, 1, 2, 3 here, or 1, 3, 2. So for other cases, 42 is not a prime, but 23 is a prime. So that doesn't work. That doesn't work because there is a 23 here. This doesn't work because it has a 13. This doesn't work because it has 13. So we need to do something else. So maybe these 4 cannot be 4, 3, 2, and 1. So how about I move, so what do we have? Because if we assume that the 5th one is already 5, then the other one I have is 5, 2. Okay, let's do that. So yeah, you need to use the choice to help you. So let me just swap, let me put 2 here, because we're going to assume that choice C is correct. So if I put 2 here, I'm going to have left with 4. So is it, well, probably that is not going to be 3, it's going to be 4 and something else. Yeah, 24 works. 43, no. 41, no. Maybe not now. So 2, 3, 4, 1 cannot be here. That means, well, should I say that 5, 2 won't work, or should we just swap something with the 6 there? Yeah, I forgot to check that one, right? Wait, hang on. Let's go back to the case where we have this. Okay, so let's say 5, 4 is going to work. So the way to still conserve the largeness of the number is to maybe just swap the 6. So I'm going to put maybe 3 here, because that's the way to make the decrease minimal. And so you swap the 6 with the 3, and then you have 1, 2, 6 left. So I'm going to have 1, 2, 6 left, right? So I can't put 1 here because 41 is a prime number. So how about I put 2, and then 1, and then 6. Ah, that already works, right? Is that the largest possible? Well, I mean, let's do something else. Let's say I have 6 here. So we see that 5 and 4 might be possible, and I get 6, 8, 7, 3, 5, 4, 2, 1, 6, right? But what if I still have the 6 here? Let's say that the 9, 8, 7 are on the right places, yeah? Let's do a 6 still. But then I'm going to change the 5th and the 6th to be something else. Okay? So how about yeah. So let's not do 5 and something. Let's do 4 and 8 maybe. No, not 4 and 8. 3 and 5. Let's do 3 and 5. Okay, so 63, not a prime. 35, not a prime. Okay, that seems to work. And then we have left 1, 2, 4. So how about 4, 2, 1? Oh, that works. And that's larger than option B that I found, right? Because option B, the 4th digit is 3, but this one. Now the fourth digit is larger, so we should go with this one, which is 3 and 5, option E. I'm gonna go with that because it feels like that's the maximum I can do. Yeah, because if I did try 4 and 8, then 8 is already taken out from the second digit. That's gonna make it a lot smaller. If I do 6 and 3, well, that's smaller than this one. Yeah, so I'm gonna go with that. Oh, I have 26 minutes. How many questions? Okay, I think I'm gonna barely make it. How many solutions are there of the equation that? Oh, okay. All right. Okay. So let's make that 1 plus 2y minus 4y squared minus 8y cubed equals 0, right? Just convert that to a polynomial equation. So the maximum roots for this one is 3, okay? But we should factorize this first. So how are we going to do that? Well, we use factor theorem. Let's say I substitute 1 in. Do I get it? If I substitute 1 in, that doesn't cancel the 0, does it? Nope. So let's try minus 1. So if I sub minus 1 in, I'm going to get 1 minus 2 minus 4 plus 8. That's not going to work, right? No. Yeah. Still not. Probably 1 over 2. How about 1 over 2? So then 1 plus 1 minus 1 minus 1. Isn't it? That works. That means we can factorize this in the form of 2y minus 1. The 1 brackets can be 2y minus 1. Then you need to find the other two. Okay? So, yeah. Let's do a long division. Well, actually, you should know short division, right? So let me show you short division. You just write the coefficient of all the polynomials here. So minus 8 in order of the degree. Minus 4, 2, plus 1. And then you do this. Okay, I'm going to need some more space there. Let me just shrink this down quick and use this thing here. And then zoom in a little so that. Okay, so the divider should be the critical value of 2y minus 1 because 2y minus 1 is a factor, so I'm going to make the critical value to be 1 over 2. So you pull minus 8 down the first step, yeah? And then you multiply 1 over 2 to minus 8, you get minus 4. And then rather than subtract from the long division method, you add. So you add them, you get minus 8. And then you multiply this again, you get minus 4. You add again, you get minus 2. You multiply this again, you get minus 1. You add, you get 0. So that is telling you that this will be 1 degree less. So the quotient here is going to be minus 8x squared minus 8x minus 2. That's the quotient from the short division. And then we're going to probably simplify this a little further, right? So if I pull minus 2 out, I get 4x squared minus plus 4x plus 1, right? And that is actually, yeah, minus 2 times x, 2x plus 1 squared, right? In this case, it's y, sorry, yeah. So that is telling me that this is actually minus 2 in front here, and this is 2y plus 1 squared. So that whole thing is just factorized to that. Now, there are two sets of answer here where y is 1 over 2 and y is minus 1 over 2 for the sine function here. Okay? So it means that, well, because I let y equal sine x, so sine x is 1 over 2 or sine x is minus 1 over 2. And in terms of graph of, I mean, you should use a CAS diagram. We have one root to be positive, so it's going to be that one and that one. Yeah, 1 over 2. And the other root to be negative, so it's that one and that one. So in one period, which is from 0 to 360, there are 4 roots, 4 answers. Yeah, so that's the answer there, 4 answers. We don't find them, we just tell the number of roots. So that's it. 19, the expression 7n plus 12 over 2n plus 3 takes integer values for certain integer values of n. What is the sum of all such integer values of the expression? Okay, probably need some space for this one. delete that and put this thing here around here. Okay, right. Okay, n is an integer like 0. Okay, so let's do, this is n. Okay, so this is n. Now let's do n like this, and then I'm gonna go from 0 here because it doesn't say minus or plus integer, and then I'm gonna do the value here, and this is a table basically. So if n is 0, if you plug 0 in there, you're gonna get 4. 12 over 3. Now let's change the number. So if n is 1, do you still get an integer? Because we want the whole thing to be an integer, right? If n is 1, it's 19 over 5. It's not an integer. So I'm just going to do that. If n is 2, then it's 26 on top divided by 7, which is not an integer. If it's 3, it's 33 on top divided by 9. 33 divided by 9, not an integer. If you keep going, 4, well, let's try 4, yeah? Okay, so 4 is 28, so it's 40 divided by 11, not an integer. Now, let's say you keep going until infinity, yeah? If you keep going until infinity, it's only gonna get closer and closer to something. If you do 7 times a large number plus some small number over 2 times a large number plus some small number, these small numbers are negligible. So basically you can assume that it's going to get closer and closer to 7 over 2, which is, you know, you can cancel the infinities here, and then it's just 3.5. I mean, look, from that, you only get 4 here, but when you approach infinity, you can only get close to 3.5. So if there's nothing close to, 4 to 3.5, there's no integer in between, because it's going to decrease to 3.5. The logic is that, so you shouldn't get any integer in between along the way. So let's do negative, right? Minus 1. So minus 1, minus 7 plus 12 is 5. 5 over 1 is 5. So this is 5 if you try plug in minus 1 in. Minus 2. Minus 14, so minus 2 on top, and minus 1 at the bottom. So minus 2 over minus 1 is 2. Yeah? Minus 3, minus 21. So that's going to make minus 9 on top. And minus 3 at the bottom, right? So that's 7. Okay, how far is this going to go? Same thing. It's going to, wait, hang on. If this is approaching minus infinity, that's going to be 3.5 as well. So we should probably keep going there. Well, at least we have this as an answer now, like option A, because at least we get 4 of them now. But could we get more? Well, let's try. Minus 4. Minus 28 plus 12, that's minus 16, yeah. Minus 8 plus 3, that's over 5. Minus 16 over minus 5, so that's not going to make it. Okay. Okay. Let me make minus 100. No. That should get closer and closer to 3.5. Wait, hang on. I'm a little in doubt with this substitution here, the minus 3. So minus 21, minus 9. Oh, no. That's minus 9 over minus 3. That should be 3, right? This should be 3. Yeah, sorry. Hang on. Let me check that again. Minus 3. Minus 21 is 9, minus 9, sorry, minus 9 over minus 3. That should be 3. Okay, that's weird. Yeah, and the minus 2 is 2. So it's going to fluctuate to the left and get closer and closer to 3.5. So if we do minus 4, we didn't get it, right? Did we? What about minus 5? So minus 5 would be minus 35. That would make it minus 23. Seems not possible there to have minus 23 on top. Okay, I think I'm going to call it at 4 here, because it's getting closer and closer to 3.5 now, because we go to the minus infinity, we still approach 3.5, which is already close here. So I don't think you can have any integer along the way to the left anymore. So the answer, in my opinion, is just 4, which is option A. All right. Number 20. Triangle LMN represents a right-angled field with LM being R and LX being P. Okay. Jin and Vicky walk at the same time in opposite direction along the edge of the field starting at X. Okay, and their first meeting is at M. All right. So one of them walking this way and the other one walking that way. If they walk at the same speed and meet at the same time, because distance is speed times time, so that means the blue path and the red path are equal. Okay, that's the logic. Yeah. Now I'm going to find the length. So the blue path is P plus R, and the red path would be Q plus the square root of Pythagoras here, R plus P squared. Hang on, no. It's just R squared plus P plus Q squared, like that. Yeah, Pythagoras. So this one is just Q here, and in the square root here is this one. All right. Now what do we need to do? Well, basically we just need to do this math. We want to get expression Q in terms of P and R. So Q in terms of P and R, we make Q the subject, but Q is also in here, so we need to crack on that first. So what I would do is just move everything here to the same side. This is quite zoomed in. So I would do this, P minus Q, like that, and plus R like this. So I move Q to the left side, and then I'm going to square this. So this becomes R squared plus P plus Q squared, like that. Yeah. Okay, so I'm going to delete this, get more space. Yeah, you can do, yeah, so you can use binomial expansion there. So the first one squared plus 2 times the first one times the second one plus R squared. Yeah, and still the right hand side there, same thing. And then I'm going to cancel R squared here because I see I can. And then what should I do with this and this? Yeah, how about, well, yeah, if I expand them all out, right? P squared minus 2PQ minus Q plus Q squared plus 2PR minus 2QR equals P squared plus 2PQ plus Q squared. Because I did this because I see that this would cancel. Yeah. So we want what again? Q as a subject. Okay, Q as a subject. I'm going to gather the term Q. I see that the term Q is in here and here. So I make Q in brackets minus 2P minus 2R. And then I move this 2PR to the other side. So you have 2PQ minus 2PR. Wait, what? Oh, you still have 2PQ here. Okay, I need to gather them. So this is also, if you move 2PQ to the left side as well, you would have minus 2P here. And then I would move this 2PR to the right side, so I have minus 2PR. Yep, like that. And then let me check the math there. Yeah, that should be fine. And then because this is all negative, so it's just the negative cancel, so I'm going to have Q equals 2PR divided by 2P plus 2R plus 2P. Oh, that's 4P, right? So that's 2PR over 4P plus 2R. And then if you cancel the 2, you get PR over 2P plus R. Hope that works. Yep, that's this one. PR over 2P plus R. Yep, so number 21 now. Triangle PQI is equilateral. A semicircle with center O is drawn with its diameter on PR so that one end is at P and the curved edge touches QR at X. Okay. The radius of semicircle is √3. Equilateral and semicircle. Okay. Okay, I see. What is the length QX? All right, we got to be careful here. The √3 is just this length and this length. So that doesn't mean the side of the equilateral is also root 3. No, it's also this root 3. Yeah. Okay, this is also root 3. What do we want again? We want the length qx. Oh, wait, what? Oh, qx is here. Okay, I'll put that as x. Yeah. Okay. Let's see what we can do here. Right. Interesting. Okay. I can see that I can make a right angle triangle there, but would that help? This is a right angle triangle because it's a triangle in a semicircle is a right angle. So I would have a right angle here. Would that help? A right angle here. And we already know the hypotenuse here, which is 2 root 3, right? And this will be an isosceles. Okay. Yeah, so this is, if we draw it like this, so that's going to make this a right angle triangle, right? And so this is also an isosceles, right? That means this angle is equal to this angle. Yeah? Let's make this angle A, right? So that's going to be 90 minus A, and this is also 90 minus A, right? Is that helpful? Maybe not. I was expecting I could find some similar triangles here actually, but seems like I can't. I have 10 minutes, 9 minutes actually. The curve touches. That should be a reason why they have touching. Yeah, but we also utilize that. Wait, this is equilateral, I forgot. Okay, so we know the angles. We know that this is 60. This is also 60, isn't it? Okay. That means wait, is this 90 degrees? Because it's tangent here, so this should be 90 degrees. Yes, this is 90 degrees because this is the center. So this is 90, that means this is 30. Okay, this here is 30. That means, okay, what's the point there? We want to find qx, so yeah, right, hang on. If this is 30, then we can find this length. Oh, it's already root 3. We can find this length. And yep, we can find this length too. Okay. If we can find this length, we can find this. Yeah, okay, got it. So that triangle there has the height of root 3, and this is 30 degrees, right? So we know that this will be what? Cosine 30. So we use cos there. So cosine 30 is equal to root 3 over something. So that thing, yeah, that hypotenuse there is just root 3 over cos 30, which is root 3 over 2. You need to know that, which is 2. So that side is 2. If this side is 2, so the equilateral is 2 plus root 3, because you need this side and that side, right? And then because we need this, so we need to do 2 root 3 minus this side. And what is that side? Well, it's just this guy right here, which if you do the triangle, you get 1. So this is just the whole thing minus 1, so it's 1 plus root 3. I think that's the answer. Okay, choice D there. Number 2, which diagram could be a sketch of the curve y equals sine of, okay, it plays with that, huh? Sine of the angle. So let's do just a normal triangle there, just to get some feeling here. So let's make this theta. Yeah, so theta is arc cos x, right? So that is just to say that if you move the cos to the other side, that is just to say that cos theta is x. So cos theta here is x. That means I do x over 1, which is adjacent over hypotenuse. So it's just x over 1 here. That means this side is 1 minus x squared in square root, Pythagoras. So the sine of theta then is just this over this, right? So this is just saying y equals sine theta, which is root 1 minus x squared. Well, we're just going to find the function that has this, the graph that has this function. So if I square on both sides, I get this, right? And if I move x to the other side, I get this. This is basically a circle. The closest one to a circle is this, right? Could be a sketch of that. Yeah, I mean, there's some limitation to the domain or range, so that's why it got cut off like that. Anyway, so that should be C. Number 23. The length of a rectangular piece of paper is 3 times its width. Okay, length is 3 times, so that's x, that's 3x then. The paper is folded so that one vertex lies on top of the opposite vertex. One vertex lie on top. Okay. Thus forming a pentagonal shape. Pentagon. Pentagon looks like this. How do you fold that to look like this? Well, one vertex lie on top of the opposite vertex. Let me just imagine that. Okay, so if I do that, okay, what's the area of the pentagon? Interesting. So if we fold this and we do that, so if I fold so that this vertex is going to be on this vertex, right? So it's going to look something like, okay, this should be like that, right? I hope, yeah, it should look like this, yeah. So it's like that. So you are folding this, go to that. So this point here is the same point as this. Okay, yeah, I'm just gonna assume that first. Well, that means, okay, and then, so this side is gonna be equal to that side, right? Yeah, because otherwise they won't touch like that. And we know now that this will be x because it's a regular pentagon, right? Pentagonal shape. It doesn't say regular, so I shouldn't assume that. It's maybe just an odd pentagon, maybe not x there. But these are definitely equal. Otherwise, they won't just align. So this side here is going to be this side here. So this is an x, this is an x, right? If you imagine, yeah. Okay, so what else? Okay. So this is the axis, right? To be a, yeah. And this side here will be, no. This side here will become this side here, right? And this length is going to be this length. All right. And we want to find the area of that. Okay, so it seems like this is already this, isn't it? And oh, so I mean, if I just can highlight the area that I should find, so basically this is this, and I think this remaining area that we should find is just this guy. Don't you think? Yeah. So if we add those up, we're gonna get the answer, but how, right? We don't have any. Oh, what is the area of pentagon as a fraction of the area of the original rectangle? Okay, as a fraction. I think we need to know this, like the base of this. I mean, I'm just gonna go with this being equal, right? I think they're equal. Okay. Yeah, I'm gonna assume that they're equal. So this is 3 over 2x, and that's 3 over 2x. That means the the area that is not counted will be 1/2 times base times height. It's just 1/2 times 3 over 2x times x, right? That's just the triangle here. So that will be 3 over 4x squared. Now the area of the rectangle, right? So the area of the pentagon would be the area of the rectangle, 3x squared. You do x times 3x minus the area of the white one. This is the pentagon divided by the whole rectangle, which is still 3x squared. X squared will cancel, right? So you have 3 minus 3 over 4. That would be 9 over 4 divided by 3. So you get 3 over 4 there, which is not right because there's no choice, equaling 3 over 4. So maybe not 3 over 2x here, but I think the logic there should be right. It's just that this side is not 3 over 4, 3 over 2 I mean. Is it 3 times its width? Yeah. Okay, that doesn't seem... Okay, but I think... oh, I'm already out of time. Sorry. I should stop the timer. And I'm going to explain all other questions properly, but let me stop the timer now. Okay, guys, I have marked the paper. So for the questions that I answered, I got 3 of them wrong, which I'll go through in a minute. And then because I left 3 questions unattempted, so there you go, 19. All right. And not too proud of that, but okay, I should do better next time. But let's go through the wrong ones. Okay. Everything is fine up until question 7 here because I didn't try it. I mean, I tried, but I couldn't figure it out. But I was close, actually. I was very close. Because when I tried to, I tried to find a difference, right? So the first 2 is 1 difference. Okay? So because you, so it says here that each term is a positive difference. So I was overthinking that the next term should be greater than the previous term. But that's not what it means. It means whatever the difference is, you're only going to take the positive number. For example, the difference between these 2 is 1. So you take 1. The difference between these 2, a positive difference, would be 2021. And the next one is the difference between these 2, 2020. That's what I misunderstood there. And then you keep going. Yeah, the next one is 1, and the next one is 2019, and the next one is 2018, and so on. Now, we want the 25th term. If you think time is not that valuable, well, you can keep going. I mean, it would be the last resort to just keep going and count the 25th term. But if you look at the pattern here, we have a pattern, right? Well, if you want the 25th term, right? So that would be from, how about the first one to the 4th one? Okay, so the first and the 4th. If you keep adding that by 3, where are you going to be at? So it's going to be 7, 10, 13, 17, 20, 23. Wait, hang on. I'll do that again. 1, 4, 7, 10, 13, 16, 19, 22, and 25. Right? So you're going to reach the term 25. Yeah, so the term 25 will be in this sequence, like the 1st, the 4th, the 7th, the 10th, the 13th, and so on. Now, why did I pick this one? Because if you have a look, the next term in this new sequence decreases by 2. You see, from 2023 to 2021 decreases by 2. This one to this one also decreases by 2. Okay? So if we make a new pattern here, yeah, what would the 25th term become in my new sequence here? Right? So we just count. Well, you can use the formula, but I'm going to count here. So 1, 4, 7, 10, 13, 16, 19, 22, 25. So the 9th term is the 9th term. Then we can use the arithmetic sequence formula because we want to find A9. That would be the first term, which is 2023, plus n, which is 9 minus 1, the common difference is then minus 2, right? So I just plug minus 2 in here. I'm going to delete this. Yeah, I just plug minus 2 in there. So what would this be? Well, I have 2023 plus, what is this? This is 8 times minus 2, so that's minus 16. So you minus 16 here, you would get 2007, which would be the correct answer there. There you go. All right. Let's have a look at the next question, yeah? So, yeah, number 12 here. I was missing a number here, honestly. Yeah, so I didn't realize that I was missing 42. Okay, so there's one more 7 here, so the correct answer should be 8. 8, yeah, so 7 to the 8 here should be like k equals 8 should be the correct answer. Yeah, so this is wrong, all right? The next one is number 19. I got all the numbers right for the end here, but didn't read the question carefully. I should have, because it asked for the sum. I found 4 cases and I got fooled by the option here, number 4, for values there. I mean, whoever designed the paper, they are quite careful here, because they're gonna try trick those of you who are not that careful, as I was there. So actually, you just sum them up. I answered 4 because there were 4 numbers, but you have to sum them up. So you get 14 actually, right? 3 plus 2 plus 5 plus 4 is 14. So that was a bit silly of me actually. And that was it. That was all the questions I attempted. And apart from that, they're all correct. And the reasoning and the explanation that I gave you should all be okay. Now let's try do the ones that I didn't try, right? Which is, I mean, I tried 23, but I didn't quite get the answer there. So let's try it again, yeah? I should be okay now. So the folding question, right? Let me just zoom in around here. Okay. So let me use that area right there, all right? Okay, so let's have a look at this one again, yeah? Okay, number 23. The length of a rectangular piece, yeah, again, we're gonna just draw, all right? So that's the rectangle, and then I have an X here, a 3X here. Now again, to fold this so that you make a pentagonal shape is to fold this to that, yeah, just like vertex to vertex folding that. So that would become something like, so you're gonna have the same of this, yeah, and assuming that you know, you're gonna have to fold so that this length would have to become the same as that length, because again, you're gonna fold this side, you're gonna be folding this side right here over this side right here, yeah? Is that okay? So you're gonna be folding this side right here to this side right here, all right? And so when you actually do fold that, you're gonna get that length there to be this one, yeah? So I'm gonna do a dotted line here, so that one cross there, okay? And then this length right here is going to be this length right here, okay? So imagine you have to fold that, right? And then imagine, right, that you would have to make it so that when you fold, right, this one will be, okay, the pentagon will look like this. So this is the same line here as that, okay? Maybe I'll use color coding. So that's the blue side, so this is also the same blue side. But then the angle between this and this, right, it's going to be the same as that angle here. So this is also a right angle, okay? So this one is a right angle, is the same as that angle. So this side is the same as that side. That means this side, sorry, this side right here is the same as that side. All right, just try and map them up there. Map them. Yeah. So let's make it let's make this side y, right? Okay. So because that's already 3x, yeah. This whole thing is already 3x. That means this side only will be 3x minus y. Cool. All right. So that means if you fold this to this, then this will also be 3x minus y. Yeah, because when you fold it, this line right here should be the same. Again, I already said that. And now because this triangle is a right angle triangle, yeah, so you can do a Pythagoras there. So let's do a Pythagoras there. So x squared plus y squared equals 3x minus y squared. Let's do a Pythagoras so that we know y in terms of x, right? So x squared plus y squared equals 9x squared minus 6xy plus y squared. Okay, so if you simplify, you can cancel the y here, and then if you simplify the x squared, you get 8x squared here and 6xy right here. If you cancel the x, you get what? You get 6y equals 8x. So that's giving you y in terms of x as 4 over 3x. Just do the fraction there. So y is 4 over 3x. Then you know this side, you know the y now. You should then know the other one because it's just 3x minus y. And when you know a lot of things here, you can find the area. So we were missing this area, right? This area we found, it was a bit wrong there because I probably used the wrong assumption there. So now we're going to use the same approach, right? Because the shaded area here is to be subtracting from the whole rectangle to get the pentagon, basically. All right, again, it's the same logic there. So pentagon, yeah, would have to, because basically when you fold, right, hang on, so when you fold, you're gonna fold this side over to, let me bring up the pentagon again. So basically this area A is going to be this area A, and this area B is going to be this area when you fold it. Yeah, try visualize that. Now, okay, so how do we find this area then? Well, if we shade the triangle part there, like the red shaded part in the pentagon, yeah, if you fold it over, it's going to be this. Yeah, but how are we going to find this? Well, if you imagine, if you fold it back to a rectangle, isn't it the same as this part right here? Right? Because when you fold, that yellow part is going to go over the red part. And the remaining bit here, let's use a blue, would then be this. Make sense? That means the yellow and the red parts are the same in area. Okay? They are the same in area. So, if we find the yellow part, it is the same as the red part. Seems like the yellow part, we know something about it. Because look, the base of the yellow part up there is 3x minus y, right? Okay? And the height is already x. So that is the area there. So 1/2 times 3x minus y times x would be the area of the yellow part, which is the red part. But y is 4 over 3x, so 3x minus 4 over 3x would be 9 minus 4, so it's 5 over 3x, so that's 1/2 times 5 over 3x times x. So that would be 5 over 6x squared. Okay, so that is the area of the red part. But the pentagon, yeah, the pentagon would be, so the area of the pentagon would be the rectangular area minus one of the red parts here. So let's see if I can do it here. So we had to do pentagon divided by rectangle, right? Yeah, that's what we have to do. So pentagon is what? So that's going to be equal to, pentagon would be, yeah, let me keep the question up here. Pentagon would be the area of the rectangle, which is x times 3x, which is 3x squared, minus the pentagon, sorry, the shaded part we already found, 5 over 6x squared. That's what I went wrong there, because I got something else there, right, if you remember. Divided by the rectangle, yeah. So we get x squared cancels, yeah. So we have 18 minus 5, so that's 13 over 6 divided by 3. So that would be 13 divided by 18, which is choice D here. Yeah, so D is the answer there. All right. Okay. 24 is actually more interesting. A square has its vertices on the edges of a regular hexagon. Two of the edges of the square are parallel to the edges of the hexagon. Yeah, you can see in the diagram there. As shown in the diagram, the sides of the hexagon have length 1. What is the length of the sides of the square? So basically, we are given that this is a regular hexagon. That means all sides, all angles equal. But the total length there is 1. And then we want to find x, which is the side length of the square. Okay? Now, you need to know that a regular hexagon consists of 6 equilaterals. Like that. Okay? So let's draw something. Let's assume that this is the exact center. Yeah, we get this, and we get that. Okay, so that's an equilateral triangle with a side length of 1. Okay, so we know that this is going to be also 1 there. Yeah, the base there, and also the other side. But we're gonna just need the base here. Now, let's have a look at this side first. So the square, we let the square length be x. That means this should be half x, right? Because this should bisect, this line here should bisect the side length of the square. So that's why this is half, yeah? Okay, what else? So that means this is also, just this part of the square is x over 2. Because it's just the same as this part, right? I mean half of this part, which is this, x over 2. So that means we know that this is going to be 1 minus x over 2, right? So this right here, 1 minus x over 2. Now, what I'm trying to get here, I'm trying to get some knowledge about this triangle, which I already have. I got the base and the height here. But you see, we want to do something about x here. Yeah, we want to solve for x actually, but this is all we have. So if I draw a height of the equilateral here, yeah, if I draw a height, let me just move this a little closer to the left, and this is here. So if I draw a height, right, like this, you know that this is an equilateral triangle. So you know that this is 60. This is 60, this is 60. Now, if this is 60, yeah, this angle here should be 30, right? Right? Because this is a right angle triangle, don't you see? Yeah? Okay. So that means this is also 30. Because look, this one, you have this, yeah? And there is a line here and a line here. These two are parallel. So this is a corresponding angle to that. All right, try make sure you understand that, or at least we know that these two are similar triangle, because these two are parallel lines and you have all angles being the same there. So that means we have a triangle where we know that this is 30, this is 60, and the height is x over 2, and the base here is 1 minus x over 2. So you can do a SOHCAHTOA. You know, so you can do, because you know these two already, so I'm going to go with 1060. So 1060 equals x over 2 divided by 1 minus x over 2, like that. 1060, you should know the basic angles for trig. You make sure you know 0, 30, 45, 60, 90. Okay? But 60 here, 1060 is root 3. Now, if you multiply by 2 on top and bottom, you're going to get x over 2 minus x. Yeah? Okay, now if I cross multiply, I get 2 root 3 minus root 3x equals x. So x is just, so if you solve for x there, you're going to get 2 root 3 divided by 1 plus root 3, right? And of course, you need to make this simplified. So from the looks of the options, we need to rationalize this. So I'm going to multiply by 1 minus root 3 there and 1 minus root 3. So the top part, you get 2 root 3 minus, that would be 6, right? Because 2 root 3 times minus root 3 would be minus 6. And the denominator would be 1 minus 3, so that's minus 2. If you simplify both two terms on the top by minus 2, you should get 3 minus root 3. And that should be option B, right? Yeah. And let's do the last bit. I'm going to add some page here. Okay, so the last bit, question 25. This one is very tricky. It's quite hard, honestly. What is the area of the part of the xy plane within which blah 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 greater than 0 and 0 less than equal x less than y? Basically, you need to shade the area where you get, like, region that satisfy all the inequalities there. Okay, the second one is fine, I guess. Let's do the second one first, yeah. So the second one, basically, let's have a crack on x less than y. Well, x less than equal y is just y greater than equal x. Now, to shade the area, it's just drawing the line y equals x first, and then shade the part above the line, right? That alone would be this part, just the part above the line. But you also need to satisfy, don't forget, x greater than 0. So x greater than 0 is to the right of the y-axis, and y greater than x, which is above this line. So that means for that inequality set alone, we have this region. Okay? That region there. All right? So I'm going to move it down here, and then I'm going to shade this part. Maybe I'm going to use a highlighter. Yeah, I hope you can see that. Yeah, so this part is the part that we got from just this inequality. Okay? What next? Well, this one, right? We can't really know how to shade that inequality without simplifying, so we need to simplify first. Well, it's not that obvious, it's quite subtle here, that you would have to maybe collect the terms and simplify, like you would have to factorize, okay? So let's try factorize that. I'm going to just pair up the positive and positive and negative, yeah? So I'm pairing up like this, and then I put a minus, and then I go like this. All right, greater than equal 0, okay? So that's just pairing up the terms. And now, because I'm going to need to focus on this, so I'm going to do x and then y squared. I get x squared plus 1, right? Yeah. And then minus, if I take the most, like the highest common factor out, so that would be x and also y squared. So I get what? X, what is here? X plus y squared. Is that right? Hang on, that feels weird. Oh, this should be y, sorry. Yeah, this should be y. Okay, yeah. So now you can factorize further. Well, don't forget this is greater than 0, okay? So you would factorize x, y squared out like that, and in the brackets you would have this. Minus as well. Just like that. Now what's the point? Well, because these two are two big terms, it's like if you look at x, y squared as an a term, and the whole brackets here as a b, term b. So a times b must be greater than or equal 0. Okay. What is the possibilities? Well, a and b, yeah, both a and b, greater than equal 0, right? Or both A and B less than equal 0, right? I mean, to make this a positive number, to make this product a positive number, you need both of them either positive or both of them negative. That should be okay. Now let's consider the negative case first, like this case, yeah, like both of them being negative. So what does that mean? Well, it means that this xy squared less than 0, or the whole brackets there, I'm not going to write too long, less than 0 as well. Now think about it. Don't forget we still need to satisfy the other part of the inequality, which is, what was it, 0 less than x less than y. That. We need to also simplify that, right? Now what's the problem? Consider this. Y squared itself is already greater than 0. I mean, we're not going to consider the case 0 here because it's just a point, right? We're going to consider a region. So I'm talking about when y squared is positive always. That would make x less than 0 to make this make sense, right? Y squared is already positive. That means x must be a negative number. Well, but we don't want x negative number. So that means this whole case fails. It's not the area we want because it doesn't also satisfy that. We should get the area that also satisfies each other in the other part, right? So I'm not going to consider that. We're going to consider instead xy squared greater than 0 and, well, or actually, that whole lot greater than 0. Now, this one works now because we know y squared greater than 0, so x must be also greater than 0. That works. That's just confirming that it's not going to contradict the other inequality. But it doesn't add any more content there, like any more meaningful result. It's just not contradicting. It is this very inequality that will help us find the answer. So let's have a crack on that, yeah? So we have x squared plus y minus x minus y squared greater than 0. Well, and this is also subtle. This is the second level now that you need to pass. You can group up like this, yeah? And let me just do x minus y on the other side. So I move x and y to the other side and x squared minus y squared on this side. Well, I can do x plus y and x minus y, right? Because that's the difference of square again. Now, do you see that you can cancel x minus y, but because from this inequality, we know that y is greater than x. That means x minus y must be less than 0 because y is greater than x. If you don't follow, think about that. Because y is greater than x, so when you subtract a greater number from a smaller number, you get a negative answer. So when you want to cancel this, you know that you are dividing across actually by a negative number. Okay? You are dividing the whole inequality by a negative number. That means when you do that, the sign should flip like that. Because now you divide the right hand side, you should get 1. And the left hand side, the x minus y goes away. Well, what is this then? This is saying that y is less than or equal 1 minus x. That is another inequality we should shade. And that is the thing that will help us find the area. So the other inequality that you should shade would be this guy. Perpendicular to that one. Yeah, because this is gradient of 1 and this is gradient of minus 1, right? This is gradient of minus 1. So this is the y equals 1 minus x. This is the y equals x, and we want the area bounded by all these, so it's going to be this region here because it's below that new line but above this line, so it's just this, and x greater than 0. So it can only be that red area. Well, we already know, right? Now the rest should be easy for you guys because we already know this is 1, right? Because it's the y-intercept of that equation. We just need to know the height here. I mean, if you take this as the base, that would be the height. Easier. Rather than finding these two lengths separately, you already know the base here, you just have to find the height. And the height in this case is the x-coordinate of the intersection. So we find the intersection, so we put the two equations equal, so x equals 1 minus x. Simple. So that means x is a half. That means this is a half. So that's 1 times, so 1 over 2 times 1 times a half is 1 over 4. That's it. That is the answer, 1 over 4. So that was it, guys. Every question I got 19 out of 25. Make sure you see other videos where I walk through, if you found me here in UKMT, I also do A-level papers. So if you haven't, just check them out there. If you have watched this far, I think likely that you find this video useful. So why not give me a follow or subscribe? And I'll see you in the next one. Bye.